Solar storms take place when a buildup of magnetic energy on the Sun is suddenly released, and now the occurrence of it has increased drastically. What if I told you that solar storms are capable of ruining the power grid for years, destroying orbiting satellites, and causing an estimated $2 trillion in damages? Now, scientists have identified the largest ever solar storm in ancient tree rings, and trust me, if Earth encounters one of them these days, it could devastate modern technology. In this video, we'll get to know about solar storms, their detection, defense, and most importantly, we'll know about the ones identified in ancient tree rings. This is a video you don't want to miss out on. Well, before we get into the largest solar storm identified in ancient tree rings, let's get to know what exactly solar storms are. A solar storm refers to atmospheric effects that are felt on Earth due to certain events that occur on the Sun. If you imagine the Sun as a bright shining light that never really changes, then you're wrong. That's because the Sun is an unbelievably huge ball of molten gases that's constantly in flux. A solar storm takes place when the Sun emits huge bursts of energy in the form of solar flares and coronal mass ejections. They send a stream of electrical charges and magnetic fields that are directed toward the Earth at a jaw-dropping speed of about 3 million miles per hour. When a solar storm strikes the Earth, this often leads to the formation of dazzling northern lights displayed in certain parts of the atmosphere that can be viewed from a plethora of areas that are adjacent to the Arctic Circle. Though solar storms help provide you with the glamorous northern light, they also lead to the disruption of satellites and various other forms of electronic communications. The beginning of a solar storm is with a huge explosion on the Sun. These explosions are known as solar flares. Well, these solar flares are not to be taken lightly, as they can be about as powerful as billions of nuclear bombs. Solar flares occur along with the release of huge streams of charged plasma that can travel at several millions of miles per hour. Now, these streams are coronal mass ejections, commonly known as CMEs. When CMEs strike our planet, they can lead to geomagnetic storms that disrupt satellites and electrical power grids. In February 2011, a CME that was produced by a powerful solar flare disrupted radio communications throughout China. According to several experts, a major solar storm could lead to economic damage which would be over 20 times that of a powerful hurricane. Scientists studying solar storms have also discovered that the frequency of solar flares follows an 11-year solar cycle. During the times of peak activity, there could be numerous solar storms each day. At other times, the number of solar storms would dwindle to less than one per week. They also estimate that the Sun's current activity cycle will result in a peak in solar storms in the year 2024. It was September 1st, 1859, the British astronomer Richard Carrington sketched sunspots with the help of a telescope when he spotted a bright oval-shaped light that expanded outward from the Sun. Just after 18 hours, auroras colored the night sky and could be viewed as far south as the Caribbean. But that was not all, as the emerging telegraph systems went insane with the melting of wires and sparks from it that set the telegraph paper on fire, resulting in the failure of telegraph networks across Europe and North America. Well, this was the result of a solar storm, and history calls this event the Carrington event. Such a rare event is more likely to occur during the peaks of 11-year solar cycles. Unlike then, humans are now completely dependent on electricity to power things. If the Earth was to come across an event such as the Carrington event, it could ruin the power grid for years, destroy orbiting satellites, and cause an estimated $2 trillion in damages. With such a risk on the line, the importance of detecting and defending against solar storms has risen. Now, a new computer model that combines artificial intelligence and NASA satellite data could sound the alarm for dangerous space weather. The model takes advantage of AI to analyze spacecraft measurements of the solar wind and predict where an impending solar storm will strike anywhere on Earth with 30 minutes of warning. This could help us provide enough time to prepare for these storms and prevent severe impacts on our power grids and other critical infrastructure. An international team of researchers at the Frontier Development Lab has been making use of artificial intelligence to look for connections between the solar wind and geomagnetic disruptions. The researchers have used an AI method known as deep learning, which trains computers to recognize patterns based on previous examples. They have also developed a computer model called Dagger that can quickly and accurately predict geomagnetic disturbances 30 minutes before they occur. The model can generate predictions in less than a second, and the predictions update every minute. There is no doubt that the best way to protect against solar storms is to forecast them in advance and shut down the grid before it's stuck. Solutions are on the progress, with some building capacitor banks that could work like batteries to absorb and dissipate excess energy. They can also install electricity dampening devices called Faraday cages, which act like force fields that can surround critical pieces of equipment and protect them from currents. Now, let's get into the largest ever solar storm identified in ancient tree rings. Scientists have discovered a radiocarbon spike dates to 14,300 years and was caused by the largest known solar storm. A similar solar storm today would turn out to be catastrophic and would result in similar consequences of the Carrington event. The research was carried out by an international team of scientists who measured radiocarbon levels in ancient trees that were preserved within the eroded banks of the Druzé River located near Gap in the southern French Alps. The tree trunks, which are subfossils or remains whose fossilization process is not yet complete, were sliced into small individual tree rings. As they compared the radiocarbon spike with measurements of beryllium, a chemical element found in Greenland ice cores, they proposed that the spike was caused due to a massive solar storm that could have ejected massive volumes of energetic particles into Earth's atmosphere. Edouard Bard, professor of climate and ocean evolution and lead author of the study, said, "Recently, scientists have found that extreme solar events, including solar flares and coronal mass ejections, can also create short-term bursts of energetic particles which are preserved as huge spikes in radiocarbon production occurring over the course of just a single year." Tim Heaton, professor of applied statistics, said that extreme solar storms could have huge impacts on Earth. He added, "Such superstorms could permanently damage the transformers in our electricity grids, resulting in huge and widespread blackouts lasting months. They could also result in permanent damage to the satellites that we all rely on for navigation and communication, leaving them unusable. They would also create severe radiation risk to astronauts." During the last 15,000 years, 9 extreme solar storms termed as the Miyake events have been identified. The exact nature of the Miyake events remains very poorly understood, as these events have never been observed instrumentally. Professor Bard said that direct instrumental measurements of solar activity only started in the 17th century. He added that now we obtain detailed records using ground-based observatories, space probes, and satellites. But all of these short-term instrumental records are insufficient for a complete understanding of the Sun. So, the radiocarbon measured in tree rings that were used alongside beryllium in polar ice cores provide us with the best way to understand the Sun's behavior in the past. Radiocarbon undoubtedly gives us a phenomenal way of studying Earth's history and reconstructing critical events that it has experienced. Cecile Miramont, Associate Professor of Paleoenvironments and Paleoclimates at IMBE, Aix-en-Provence University, said, "Finding such a collection of preserved trees was truly exceptional. By comparing the widths of the individual tree rings in the multiple tree trunks, we then carefully pieced together the separate trees to create a longer timeline using a method called dendrochronology. This allowed us to discover invaluable information on past environmental changes and measure radiocarbon over an uncharted period of solar activity. Well, what do you think about this solar storm and its effects? If you enjoyed this video, then don't forget to like, share, and subscribe so that we can entertain you with more new videos from the cosmos.